Welcome back and thank you for joining. Let's practice some more simplifying of radical expressions. And this time we're looking into radical expressions that contain a variable in the radicand. So recall that the formula that we're using in simplifying these radical terms would be the nth root of a to the power of n equals a. So we'll try to express the radicand as a perfect power with power same as the index. Now, to better understand how to simplify when a variable is present in a radicand, let's take a look at how we simplify when the index is odd or even. So remember, there are restrictions when we take the eventh power of a number. The eventh power of a number can only be, let's say for example, the square root of 4 is a positive 2. And we can only take the square root of a positive number. The same applies to fourth root, sixth root, or any eventh root. So whenever we simplify eventh roots, we need the radicand to be positive. Now, if the root is odd or the index is odd, radicand can be any real number. So what that means is that if we have the third root of 8, that would be equal to 2, and the third root of negative 8 would be equal to negative 2. So both radicands, positive and negative, can be cube rooted or third rooted. However, if the index is even, we want to make sure that the radicand is either positive or equal to 0. So, for example, if we have the square root of number 4, that would be equal to 2, but the square root of negative 4 will be non-existent. Now, when we have a variable in the radicand, and we're simplifying it, say for example, if we have the square root of x squared, the answer will be x. But if x happens to be a negative number, let's say for example, if we had the square root of negative 3 squared, so, and x, let's say, is negative 3, if we admitted that the root of x squared is equal to x, it means that we need to admit in here that the square root of negative 3 squared is negative 3, which is unacceptable for the square roots. So there are 3 cases that I would like to bring to your attention. First of all, always remember to identify the index, and that is because if the index is even, radicand has to be positive. And the way we ensure that we get the right answer is by looking at the following 3 main cases. So there are other subcases which we won't talk about. Case number 1, if the power is odd, so when we take out an odd power, for example, if we have the square root of x squared, the answer would be x, so to the power of 1. So number 1 is an odd power. So in this case, we're going to say that the term that we take outside, or the variable we take outside, if it has an odd power, we'll need an absolute value to make sure it stays positive. Because if x happens to be a negative number, then if we stated that the root of x squared is simply x, then we would admit also that x can be a negative number, or the answer is a negative number. So in this case, to protect the answer from being a negative, remember, only for eventh roots, right? So we need to make sure that we put absolute values around the answer. Now, case number 2 is when the answer we obtain has a power of 2. So we say that this is the case when we take the eventh root of a number and we get an answer with even power. In this case, x to the power of 2 will always be positive because x to the power of an even number is positive for any real number. That means that the answer that we get from the even root will be a positive number at all times, so there is no need for absolute values. Case number 3 is what I call the protective radicand. This happens when we have, let's say for example, a radical number with even index, and when we simplify it, we take out a factor that has a power of 3, which makes us think of case 1, where we need the absolute value. However, in this case, we're going to say absolute value won't be necessary because the fact that we have x to the power of 1 inside the eventh root in here guarantees in a way that x is positive or equal to 0, which protects x to the power of 3 from being negative. So with this in mind, we're going to go over a couple of examples here. So we have to simplify 9x to the power of 4. So again, you start off from the index. So the index is 2, which means the index is even. So when we take out or we simplify this radical term, we're going to say that we need to express the radicand as a power of 2. So number 9 is a perfect power of 2 with base 3, and x to the power 4 is a perfect power of 2 with base x to the power of 2. So 2 and 2 simplifies, and the answer is 3x squared. And before we leave this question, we are going to make sure that whatever we simplified, whatever we took out of the radical, is a positive because of the even index. So 3 is a positive number, and if x is positive, x squared is positive. If x is 0, x is 0. And if x happens to be a negative number, so we'll still have a positive answer. So therefore, there is no need for absolute value in this particular question. Let's continue with the next one. We have the square root of 16x squared. Sorry. So here we go. We have the square root, index is 2, which means we need to write this as a perfect power of 2. 16 needs a base of 4. X squared needs a base of x. So the answer now will be simplify the 2's in here, simply 4x. Now, number 4 is a positive number. Now, x has an odd power. So remember that if x happens to be, let's say, a positive or equal to 0 number, that would be a perfectly acceptable answer because we can square root a positive or a 0 and get a positive or a 0. But if x happened to be a negative number here, we wouldn't recognize it right away in the radicand because it would still be negative to the power of 2 equals a positive. So, but when we take it out, then if we admitted that we had just x in here for x, that means that if x were a negative, we would get a negative answer here. So that means we're going to need an absolute value to protect x from being negative. So, and to make sure that the square root of this term is some positive number. Now we'll move on to the next question. So if this is still confusing, try to go back to the chart, analyze it, try to recreate the chart on your own. It makes more sense when we recreate things based on our own understanding. So again, we have an index of 3. Remember then when index is odd, we do not have to worry about making the term outside the radical a positive or ensuring that the term outside the radical is positive. So we're going to need, though, a perfect power of 3 here. Number 8 will need a base of 2, and a is simply a. So the answer would be 3 and 3 simplifies 2a. So this can be positive, negative, doesn't really matter. That's an odd index, that's why. Continue on with the next question. We have negative 49. B to the power of 4. So this negative will sit quietly here in front of the radical. The index here is 2, which means that we need to express the radicand as a perfect power of 2. 49 will need a 7. B to the 4 will need a b squared. So that would equal negative. And we'll simplify these two and we'll get 7b squared. So because the index is even, we want to make sure that we took out a positive, and 7 is positive. For any number or value of b squared will be also positive, so this will not need an absolute value. So next we have plus or minus the square root of 64x to the 4, y to the 4. So we have plus or minus the fourth root, sorry, let me double check this, the square root, I don't know, a lapsus. All right, so we have the square root, and we have to write this as a perfect power of 2, this radicand right here. So let's think about it. Number 64 as a perfect power of 2 is going to need the number 8 in here. 8 times 8, 64. For x to the power 4, we're going to need an x to the power of 2. For y to the power 4, y to the power of 2. So let's continue simplifying here. We have a plus, minus, index and power simplify. So this would be the answer, 8x squared, y squared. Now let's discuss the value of the term we took out outside the radical. Because index is even, this has to be even. This has to be positive. 8 is positive, x squared is positive for any real number x, y squared is positive for any real number y, which makes 8x squared y squared a positive. So let's continue with one more question. So here we have an odd index. Odd index means don't worry about absolute value at all. So we're going to say that this is the third root. We still need to simplify it, right? And we need to write the radicand as a perfect power of 3 so that we can simplify as much as we can. So number 27 will need a base of 3. So to the power 3, 27. And y6 is going to need a y squared in here. So index power simplify, we have 3y squared. And again, index odd, no need to worry about making this positive. Next, we have another odd index. So index of 3, which means that we're going to have to rewrite this radical number as third root of a perfect power of 3. So negative 125 will need a negative 5. Y to the 6 will need a y squared. So that means we have 3 and 3 simplified. The answer is negative 5y squared. Let's continue with the next question. We have an even index here, so be very careful. So that means we are trying to rewrite the radicand as a perfect power of 4, same as the index. So power 4 stays out. So x to the power of 20 will need an x to the power of 5 in the base. Y to the power 16 will need a y to the power of 4 in the base. So same idea. They simplify, and we'll have x to the power of 5, y to the power of 4. Now, let's check and see what this term can become. So, if x is any real number, which means x can be positive to the power of 5, this is positive. X can be 0 to the power of 5, that would be 0. Totally acceptable, because the roots of positives and zeros can come out of an even root, right? Or numbers that are positive or 0 can come out of an even root. But if x happened to be a negative number, then that means that this would be a negative number. And that means that we agree to take a negative value outside an even root, which cannot happen and shouldn't happen. So that's why we're going to wear x to the power of 5, some absolute value, nice little winter coat here. So y to the power 4 will be positive for any real number y. Now there is something else that we can do to simplify this answer in here. Notice how we have the absolute value of x to the power 5. 5 is quite a big number. So we can simplify this a little bit further by rewriting this term, x to the power of 5, as x to the power of 4 times x to the power of 1, and then y to the power of 4. Now, x to the power of 4 can come out of the absolute value because it is positive for any real number x, and then we can keep just the absolute value of x inside the absolute value notation, and then y to the power of 4. So either version that we just wrote, or x to the 4, y to the 4, absolute value of x are acceptable. Now this would be considered a more simplified answer than this one here. So we'll continue with the next question. We have again an eventh root. So we gotta watch out for the number that we take out of the radical. So eventh root means that we're going to need in here a power of 2, same as the index. So number 4 will need a base of 2. Y to the 4, a base of y squared. 2 and 2 simplifies. Answer is 2y squared. And y squared is positive or 0 for any real number y, therefore no absolute value. Okay, so next we have negative, so that's outside the radical. The third root of 27 x to the power of 9. So this time the root is odd. That means we don't have to worry about ensuring that the number that we take outside the radical stays positive. So, but we do have to write this as a perfect power of 3 because we're still simplifying. So 27 is going to need a base of 3. X to the 9 will be x to the power of 3. And the answer will be, simplify the 3's in here. We still have the negative sign in here. And we have 3x to the power of 3 as the